Right, so yesterday we looked at arithmetic series. Today, the other type we like to look at, geometric series. Now the only difference with the geometric pattern is instead of adding a constant amount, we're multiplying by a constant amount. And so that constant amount we call the common ratio rather than the common difference, and then creatively we give it the symbol R for ratio. So if we wanted to work out the ratio, instead of subtracting, we would now divide. So second term divided by the first term, or the third term divided by the second term, or we could pick any term divided by the one before. Now this is where we've got to be careful though. Yesterday I said with arithmetic is it doesn't have to be consecutive ones. You could pick, say, the 6th and the 12th. Now if we pick the 6th and the 12th in a geometric one, we might have a problem. Because if you think about it, it'd be 6 ratios, so it'll be r to the power of 6, which is an even number. And so you get two possibilities, plus or minus. So ideally, you would like terms that are sort of like an odd number apart to work out whether it's positive or negative. I mean, they might give you other information so that you can work it out. Otherwise, if they've only given you enough information to say, well, I know the ratio is plus or minus, then I guess you've got to say, well, there's two possible patterns here. I could be multiplying by a negative number, I might not be. So the recursive formula for that would then be to get any term, you multiply the previous term by whatever the ratio is. So using that idea to generate our general formula, first term's A, so to get the second term, multiply the first term by the ratio, AR. To get the third term, multiply the second term by the common ratio, AR squared, and the pattern starts emerging that any particular term is AR to the n minus 1. So, alright, so here's our pattern. 2, 8, 32, we're going to find what the ratio is and the general term. So we can really just look at this because we've got the consecutive ones. 8 divided by 2 is 4, so there's my ratio, and the first term, of course, is 2. So my general term, AR to the n minus 1. So A is 2, R is 4. So I've got 2 times 4 to the n minus 1, which, yes, I guess that is a formula, and it is a general term, but we can make it a lot neater there because you'll notice 4 can be rewritten as 2 to the power of something as well. So we can play around with the indices with this one and say, well, 4 is 2 squared. So 2 squared to the power of n minus 1, power of 2n minus 2. And then times 2, well, we add the powers, and we come up with a neater formula there of 2 to the power of 2n minus 1, which is a lot easier to substitute into. Alright, so this is what I was talking about. They're giving me 2 terms, but they're an even distance apart. We've got the second term and the fourth term. So there's going to be 2 ratios between them. So AR is 7, AR cube's 49, which means R squared is 7. So what do we know about R? Well, it could be plus or minus root 7. Without more information, we don't know which one it is. So we put down both possibilities. So in this one, which one will be the first one greater than 500? So first term is 1, the ratio is 4. So my general term is 1 times 4 to the n minus 1. Well, that's just 4 to the n minus 1 because obviously 1 times anything. We want to know when is that greater than 500. Exponential equations, or in this case, inequation. Yes, you could use trial and error. And like pick a number and see if you can find the right one, and you might have to substitute a few in. But if you remember logs, it makes life a lot easier. And so what do we do with logs? Well, the first step is log both sides. Gee, how do we do that? It's real tricky. We write the word log on both sides. So this is our new equation to solve. But by doing that, I don't know whether you remember it or not, but we've got a log law that says the power there I can bring to the front of the log. And so I now can say n minus 1 times log 4 is greater than log 500. I can now work out n, because I'll divide both sides by log 4, and on the right hand side I get 4.48. So I now know n is greater than 5.48. We want the first whole number, so n is 6. So it's term 6, which turns out to be 1024. Couple of things to keep in mind when you're using logs. The base doesn't matter. as long as you use the same one. Now you've got two log buttons on your calculator. You've got the one that's labelled log, you've got the other one that's labelled ln. It doesn't matter which one you use, you'll get the same answer as long as you use the same one for both. Okay. And the other thing to keep in mind is a log of a number that's smaller than 1 is a negative number. So had this been on the left hand side, n minus 1 times log of 0.5, when I divide, I'm actually dividing by a negative number. Therefore, if you change the sign, you would have to move the inequality sign around. So keep that in mind if you're using the log technique. It's usually pretty quicker than trial and error, just picking numbers. I mean, you might get lucky and hit on the right numbers straight away. Okay, so 6 of these, some geometric ones to look at.